So hello and welcome to video number 4 of a video series that I thought would only last 2 videos. So this is a bit more about the notation in chapter 3 and the entire setup in chapter 3, where I just talk about different types of products that we're introduced to in chapter 3. So the one that we are going to look at now is called the temporary life annuity do. And the thing that the temporary life annuity do is, well, it's this. It is, so a temporary life annuity do pays out 1 unit at time t if you are alive at time t. Time t all the way up to time n minus 1. Where n is the year of expiry. So the way we look at it is like this. If I draw a timeline, then a temporary life annuity do with expiry n starts its payout in time 0. So this is where the first payout is. And then at time 1, there's one more, and then at time 2, and then at time 3, and so on. So depending on when you die, the payout will occur at the payout will stop at different times. So for example, if I die somewhere between, if the X-year-old dies somewhere between year 3 and 4, then that means that there will be no more payouts. That there will be no more payouts after time 3. Now, if the person on the other hand is so lucky that he or she lives past expiry, then that means there will be payouts all the way up until time n minus 1, where the last payout will be. So this is the case where, for example, tx is up here. Now, again, what we see here is one of these cases where the benefit that is paid out depends strongly upon the realization of the lifetime. So the way we write this is b of t is equal to 1 if and only if we're standing at a time t that is before our time of death, and only if t goes from 0, etc., up to time n minus 1. Now in the book you might notice that they write t going from 1 up to time n minus 1. We can also do that, but you just should know that the reason why we do that is because, well, it is because at time 0, we just know that the X-year-old is alive, right? So there is no reason for this to depend on tx as such. So then it is just equal to 1. Now, the expected present value at time 0 of this is pretty interesting because you might recall that in the term insurance case, where we were looking at payout in the year that the insured dies, what we wrote up at that point was that the expected present value, also called V of 0, is given as the expectation of the sum of t going from 1 to n of the discounted value of each of the payments at each of the time points. Well, if we're talking about the expected present value of benefits. However, The thing is, if you look in the book, then they actually tell you that the EPV at time 0 is equal to the expected present value of the sum from 0 to n of e to the minus delta t multiplied by this b of t, which in our case is the indicator that there is survival past time t. So then you might ask, well, why do we have 0 here, and why did we not have 0 before? So the reason why there's 0 here is because normally when we look at expected present values at time 0, what we are really interested in is the expected present value of all future payments and including the present payment. However, the notation v of 0, so v of 0 denotes the expected present value of payments strictly in the future. So of payments strictly in the future, which means if we're looking at discrete time and we're standing at time 0, then v of 0 only takes into account the payments that occur from time 1 and forward. However, in this case with the life annuity due, there is a payment that falls at time 0. And when we price the contract, it's also important that we ask the customer to pay for that as well. So that is why when we look at the expected present value in this case, in the book they say we take the sum from time 0. So notation-wise, we are actually not able to write that this is equal to v of 0 because that would be wrong. However, what we write is that it is equal to v of 0 from the left. That means we kind of stand like right before time 0 and look at all of the future payments right before time 0, which will also include the payment in time 0. So that was the one about the temporary life annuity due. You guys might want to know why it's called temporary. That's because there is an expiration date after year n, and the reason why it's an annuity due is because due means payments fall in the beginning of the time unit and not of the time interval and not in the end of the time interval. So I hope that this was of some kind of help to you. If it isn't, then please write me an email and let me know, and then we will try to take a quick session with this by the blackboard, because it is a new concept that you are presented with in chapter 3, and we haven't spent that much time looking at it. So please write an email if there's anything that's still bothering you. The notation is hard to understand, so spend a little bit of time looking at it. In the next videos, or probably this will not be uploaded together with problem 3.8, but I will continue on to solving problem 3.8 in the next videos.